This is page 18. Okay, so in order to see the limit, the two limits in the previous videos are the same, we need to prepare two lemmas for the next section. The first lemma. Okay, suppose ft, gt are continuous and adapted stochastic processes. And phi t and psi t are continuous instantly independent stochastic processes. Assume that f t phi t equals gt psi t. Then there exists a continuous function which is of course deterministic, alpha t, such that gt equals to alpha t times ft and phi t equals alpha t psi t. And here this is a proof. By the assumption, I put this as equation star. By equation star, gt over ft equals phi t over psi t. And by the way, here we assume that ft and psi t, they don't take the value 0. It's a technical, if they are 0, it's very technical to verify. Okay, but nevertheless, that can be done. And now, this is adapted. And this instantly independent. Here, of course, we need, in general, we need to assume that the product of two instantly independent, or the product of the quotient of two instantly independent stochastic processes is are also instantly independent. So in that case, the left hand side is adapted and the right hand side instantly independent. Therefore, by the above theorem, hence, let me put this as alpha t. And alpha t is a continuous, hence alpha t maybe here is a deterministic function. Here, alpha t is a continuous function. Thus, we have gt equals alpha t ft and phi t equals alpha t times psi t. Okay, we go to the next page. This is page 19. Now suppose we have this equality ft times phi t equal to, now the right hand side is not just one product, but it's a sum of two products. Is oh, here, let me put this as g sub 1 t psi sub 1 t plus g sub 2 t psi sub 2 t, where I don't write, but the f g1, g2 are supposed to be continuous adaptive stochastic processes, and phi, psi 1, and psi 2 are assumed to be continuous instantly independent stochastic processes. And suppose this equality holds almost surely for all t. Then what is the relationship between those stochastic processes? You see, a stochastic process as a product, it can be represented by the right-hand side. It can be also represented by the right-hand side. It's possible. And we need to address this issue. Okay, so to find out the answers, that it to be the expectation of phi t. B1, I'm sorry, this is A is a function of t. And B sub 1 t is expectation of psi 1 t. And B sub 2 is the expectation of psi sub 2 t. Oh, I'm sorry, this is B sub 2 t. Then, upon taking conditional expectation of equation, well, that's, let's put this as double star. We have, what do we have? Since ft is adopted, we can pull out of the conditional expectation. And then the conditional expectation of phi t, because phi is instantly independent, it is the same as the expectation of phi t, which is at. So we have at here. And that equals to, similarly, the right-hand side, we get b sub 1 t and g sub 1 t plus b sub 2 t and g sub 2 t. And now we divide both sides by b sub 2. And again, we may assume that this is non-zero. And then I'm going to put here a tilde t equals to at divided by b2t. And b1 tilde t to be b1 of t divided by b2 of t. Then we have, what do we have? A tilde t ft equals to b1 tilde t g sub 1 t plus g sub 2 t. And then we solve for g sub 2t. Hence, g sub 2t equals to a tilde t ft minus b sub 1 tilde t g sub 1 t. Let's put this as equation 2. Okay, now put equation 2 into equation that's okay. To equation double star. Then what do we have? We have ft phi t equals to g sub 1 t psi sub 1 t plus wait a second. Okay, plus this B2, I'm sorry, G2. Oh, I'm sorry, here, G2. G2 is A tilde T FT minus B1 tilde T G1 T. This is G2 from equation 2. And that is, we put it over here. And then times psi sub 2T. Now we go to the next page. Wait a second, the video is getting too long. So okay, let's stop here, stop this video, and then we continue.